Okay, now we will simulate the friction and momentum. For the friction, it is actually not applied by using force directly, but it is set up using what we call physic material. It is actually an asset in Unity. Notice the absence of S here. In the 2D version, we use physics material 2D. But here for the 3D version, it is actually called physic material. Just as Unity, why they name physics and physics material for 3D, but physics material 2D for the 2D game. Okay, let's create a new folder. In the assets folder, create a new folder named materials. And then we will create a physics material. Be careful. Select the physics material, not the physics material 2D. Name it anything you wish. I will leave it as it is for now. Okay, we are told to name it hard surface. Let's do that. Hard surface. For the properties, now you can see we have a dynamic and static friction. In the 2D versions, we don't have these properties. You can set the dynamic and static friction coefficient in the dynamic and static friction. And you can also set the bounciness or the coefficient of restitution here. But now we have two more additional properties. Two additional properties: friction combined and bounce combined. For these two properties, we have some values to choose from. Average means that we will average from two materials. Maximum, minimum, Unity will take the max or minimum values from the two materials. Multiply, Unity will simply multiply both materials for the friction and bounce values. Okay, let's try for the friction one. Let's create a new scene. We'll name it friction. And then create a plane x, y, z is 0. Let's create a plane 3D object plane. Reset to 0, 0, 0. And then let's add a cube on top of it. Y is 10. Maybe I will scale my plane to be bigger. And then we create a cube, but move it y equals to 10. It's quite high up there, but let's continue. And then apply your hard surface material to the panel. This one to the, sorry, not panel, but plane. Add, where is it? On the collider component material property. Okay, let's try to find the, this one, collider. We have a material here, just drag the hard surface and drop it over here. Okay, let's say I want to modify my hard surface for the static friction is 0.8, but the dynamic friction is 0.5. Okay, and then we can attach a rigid body for the cube. Rigid body, let's just leave it as it is. Obviously it won't move. And actually to test the friction between these two things, we must apply some force. Okay, let's try it. I will create a very simple script here. If I click the, if I left click, not necessarily on the cube, but if I click anywhere in the game panel, then I will push my cube. Yeah, so I think I must move my cube not really high, maybe something like this. Yeah, and I will restrict it from rotate. Yeah, so I will freeze rotation X, Y, and Z. I would allow my cube to be able to rotate when hit by anything. Yeah, and then I will create a very simple script. Let's name it push. Then attach it to the cube. Hit it. Okay, we have a public vector tree push force, and let's delete everything. We add the fixed update method instead. Okay, we will detect if the fire1 button is pressed. Yeah, if input get button down, fire1 is pressed, then I will apply a rigid body. Okay, okay. We must add the private rigid body field. Yeah, P, and for the start, we shouldn't have deleted it. Okay, let's add it again. Start rp dot get rp equals to get component rigid body. Then here, let's just add force with the value of push force, but we will use the impulse mode for now. Yeah, because we only want for the force to be applied only once. Yeah, that is when we click the get, sorry, not click the get button down. Yeah, but when we push the fire1 virtual button, which is left click or left control. Okay, and then at the cube, make sure you have attached the push script. Yeah, and let's see. For the push force in the Z direction, I will give it a value of 10. And yeah, maybe we will need to scale up our plane later, but let's try this first. Yeah, click once. Oh, it's too... Yeah, our cube moved very fast. Then let's decrease the push force maybe by 1. Okay, click. Not really a great push force. Maybe 5? Yeah, I think 5 is enough. And as you can see, yeah, as you can see here, if I click, then my cube is pushed forward, but later it will stop, yeah, due to the friction between the cube and the plane. Now, what happens if the plane, I will stop this play mode first. Yeah, what happens if the plane actually set to have no friction at all? Yeah, and I will decrease the push force into something smaller, maybe 2. Or for comparison sake, yeah, let's leave it to 5. Yeah, as you can see now, my cube stops at the very edge of the plane. Yeah, but it does not fall down because I already restrict the movement or the rotation of my rigid body. Yeah, however, if I turn this off, then my box will simply falls down. Yeah, maybe I don't want to rotate it in the X and Z only. Yeah, but I will leave it to be able to rotate in the Y axis. Yeah, I think that's fine. Now, let's change the friction combined into the maximum. Yeah, for the maximum, Unity will use the maximum value for the dynamic friction and static friction. Yeah, because the cube does not have the hard surface or any physics materials surface. Yeah, not physics material surface, but physics material to the material component or the material property of the box collector. Yeah, it uses the default value. Yeah, the default value is actually what Unity provides us when we create a new physics material. So the dynamic friction is default to 0.6. Static friction is also default to 0.6. Yeah, however, if the friction combined is set to minimum, then my box will not stop moving. Yeah, because remember, if you have a zero static or dynamic friction, then there is no friction at all. Yeah, that's why my cube does not stop moving. Okay, so that's all for the friction. Yeah, I will leave you for the exercise. Yeah, to simulate the momentum one. Yeah, please recreate. The first one is the collision between two moving objects. Yeah, maybe cubes or spheres, and collide them and see what is the reaction between them. Yeah, the second one is the bouncing ball. Yeah, please set up for elastic, inelastic, and real collisions as well. Yeah, you can create different scenes for this one, or you can combine it into one scene. Yeah, but make sure you set up for elastic, inelastic, and real collisions. Yeah, this one is actually a homework for you, so please submit it within the stipulated deadline in the classroom. Yeah, but if you have any questions, please don't hesitate to ask me in the Hangouts group chat as usual. Okay, so I think that's all for today. Yeah, we have already learned quite a lot. Yeah, actually, it's roughly the same as our first part of the semester, but now we simulate all of them in 3D work. Yeah, I hope this will spark your interest more in Unity. Yeah, either by trying to simulate physics in Unity 3D, or later on, maybe you want to expand your knowledge by creating a 3D game in Unity. Yeah, but for now, we have simulated the physically based animation in Unity. Yeah, should you have any questions, again, please don't hesitate. Just ask me in the Hangouts group chat. Yeah, next week we will learn something new. Yeah, learning what? Just wait for the next week. Yeah, and okay, that's all for today. Thank you for watching and joining with me until the end. Yeah, we will meet again next week. Bye bye.